I am very satisfied with the ground we have covered so far, and I really hope it is the same for you. It's now time to take everything to the next level, starting to actually perform EDA on our data. To do this, we will start looking at the distribution of our data assumed and the summary statistics able at summarizing these distributions. Well, I'm sure you already know what we are going to do now, that are facing two new concepts. Let's define what a distribution is and what summary statistics are before trying to analyze them on our data. The distribution of an attribute is basically the way this attribute is shared among the elements composing our population. A really famous example you can find represented here is the income distribution, which shows how incomes are spread among a given population. For instance, citizens in a country. On the other side, summary statistics are single measures trying to summarize in a value a whole distribution. They can be considered as typical or representative values able to effectively express the behavior of the attribute we are looking at. Well, a really famous and common example that you probably already know is the mean, also named average. Well, that is a summary statistic. You have to know that when I say to my kids to do something, they always start asking a never-ending series of why, and they are never satisfied with my answer. Well, even if this sometimes can become exhausting, I actually think it is a good practice which helps you get a proper understanding of matter you are facing. So let's try to apply this technique also to our question. Why should we look at the data distribution? So why we are going to spend time learning this? Well, we have here at least two different possible answers. The first one, because a lot of statistical machine learning models require our data to possess a specific distribution, like for instance the normal distribution. And a practical way to check the satisfaction of this requirement is to look at our data and look at their distribution, as you can see in the plots that are represented here. The second possible answer is because looking at variables distributions, we can easily discover if any of the variables assume a distribution which practically makes it useless for our purposes. To get the second point, you can just think of a variable assuming almost always the same value, which is the informative power of that variable. Yeah, you've got it. None. Something similar, but not identical, holds true for summary statistics. Since they are able to summarize distributions in a number, or maybe a pair of number, those statistics are a really convenient tool for performing comparison between attributes or even partition of the same attribute. Think, for instance, at computing the average salary by age or by sex, as you can see represented here. In this case, you are grouping your population by an attribute, which is the age, as we were saying, and then computing the average of another attribute, the salary, for every subgroup you have found based on the age. Another typical example are time series analysis, where you take, for instance, the average salary by year, so to observe the evolution of this attribute during a given time span. Another useful use is for the computation of other statistics. We are not going to get into details of these here since this is out of scope of this course. But since summary statistics are able to summarize distributions, they are often used to perform tests on those distributions. This is especially true for what is called inferential statistics, like, for instance, testing if the average level of salary for two different age groups is significantly different or not. Well, there are even more reasons for analyzing distributions and summary statistics, but I hope this that we have seen already gave you some hint about why it is important to master these concepts when performing your exploratory data analysis, and so why it is important to watch the following videos within this section. Okay, so before moving on and actually starting to analyze distribution and summary statistics, let me introduce two more concepts that we will employ and therefore need in the subsequent videos. The concept of categorical variables and numerical variables. Limiting the theoretical burden to the minimum, we can say that categorical variables are those where the range of possible values is not numerical, but rather composed of categories. Those categories can be both arrangeable on a scale, like for instance from worst to best, or not, like is the case for instance of the animal species, which are represented here. Then, talking about numerical variables, we could simply say that those variables are those not categorical. But we can also introduce one further detail. Numerical variable can be distinguished between continuous and discrete ones. To get continuous, we can think again at salary. It can range from 0 to theoretically infinite, and it can assume any value in between, including decimal numbers. On the other side, let's think, for instance, at the number of sons. Can anyone have 2 sons and a half? I guess no. So, to completely cover this topic, we can add that the continuous variables can be transformed into discrete variables, and also categorical variables can be transformed into numerical ones. The first objective, which is transforming the continuous into discrete or categorical variables, can be obtained through what is called binning. This simply means that you take your variables and you place its possible values into bins. So getting back to salary example, you can create bins like from 0 to 1000, from 1000 to 10,000, from 10,000 to 50,000, and so on. Well, the critical point here is to find a robust way to define the span of each bin. So as you can see now, you have taken the continuous variable of salary and you have made it divided into bins. You have made it like a categorical variable because you have now the first bin, the second bin, the third bin, and all the possible values are included within these bins. On the other side, categorical variables can be transformed into numerical with tools like the weight of evidence, which we are not going to deepen here, but it is a tool you should take into consideration if dealing with categorical variables. This is a useful tool because it allows you to apply on your variables models that would be otherwise impossible to apply. Okay, then let's recap what we have just seen here. The concept of distribution and why it is important for our analysis, the idea of summary statistics, and their possible use, and the distinction between categorical and numerical variables.